Welcome everyone. We are going to do this 2D motion lab, but we are going to do it virtually for you. So hopefully you watched the intro video already, but here is what we're gonna go through and collect the data. So we have our ramp on the far left, we have our photo gates 1 meter apart. So in your lab report for part 1, the distance we're gonna roll this marble is 1 meter apart. I'm gonna roll this 5 times and gonna let the computer record the data, and then I'll kind of zoom in for you to kind of get that, to collect that data for you. So here we go. All right, so we actually did that 6 times because the first time it hit the photo gate, so we aren't going to count that one. So now for part 1, you are going to record 1 meter, and you want to record this time, this time, this time, this time, and this time. So those are the 5 times you need to record for part 1 time. It rolled 1 meter, distance rolled is 1 meter. Those are your times. So go ahead and hit pause and record those 5 times. All right, now that you have those recorded, you can go ahead and you can do the calculation to determine how fast the ball was rolling across the table. From 1D motion, remember your acceleration across the tabletop, your velocities are constant, so your acceleration is 0. It's a 1D motion problem, moving across the tabletop. Fab 5, equation number 3, figure out your velocity for part 1. When you're done with that, go ahead and unpause this video. See you in a little bit. Now that you have part 1 done, we can do part 2. And for part 2, we're gonna roll the marble down the ramp, across the table, let it roll off the table, and hit that carbon paper that is sitting on the floor. We're gonna do this 5 times. It'll make 5 marks. So here we go. One second. All right, now we're gonna have to measure those. So I took off my carbon paper, and hopefully you can see those blue dots on this piece of paper right here. That's from where the impact of the marble was. I will read off the numbers, and you will then have to record those numbers, and I'm gonna give them to you in centimeters, and you need to convert those to meters. So remember how many centimeters there are in a meter, right? So, and data table number 2, 46.7 centimeters. 46.7 centimeters. Data table number 2, we have also a 45.6 centimeters. 45.6 centimeters. For the third trial, we have a 46.1 centimeters. We have 45.4, 45.4, and last 45.3, 45.3. So average those 3 trials for part number 2, and then we'll talk about the last part. All right, you've calculated, you've calculated your velocities for part 1. We measured some distances for part 2. Now calculation for part 3. Part 3 is a 2D motion, horizontal launch, projectile motion problem. The only thing you're going to use from part 1 is that velocity that you averaged out. That's going to be how fast the marble is rolling across the table. And that's how fast it was moving as it rolls off the table in the X direction. The last thing we need to determine is we need to determine the height of the table, and we can measure that. And then once we know that, we can go through and calculate your delta X, how far from the edge of the table should it have landed. So the part 3 calculation that you're gonna do is our accepted value. The part 2 calculation that we actually measured, that's our experimental value. And then because for part 5, I'm asking you to do a percent error calculation. So part 1, you determine speed on the table. Part 2, you measured how far from the edge of the table. Part 3, you calculate how far from the edge of the table it goes. And then the final piece is going to be a percent error calculation. The last piece we need to give you for data for your part 3 calculation is the height of the table. So here's the final piece of information you need. You need to know the height of the table. Again, this is going to be in centimeters, so you're going to have to convert it into meters. But the height of the table is 91.3 centimeters. So that's your delta Y. But remember, delta Y is going down.